Let's look at some of the example data from my Stanford students. So here's the distribution of homework again in hours per week. And we saw that in an earlier module, the mean homework was 11.4 hours. The standard deviation for homework was actually 10.5 hours. So that's a pretty big variability, right? So on average, students are doing about 11 hours of homework, but the average variability is 10.5. So that means many students were doing down towards 0, and many students were doing 20 or more hours per week. So pretty wide, a pretty large variability here. Let's look at our feelings about math from my Stanford students. So again, pretty wide variability here. I asked the students to rate their feelings about math from 0 being really hate math to 100 being they really love math. And the mean in this particular variable turned out to be 61. So on average, people are favorable, although not highly favorable towards math. But the standard deviation, again, was fairly high. It was 21. So you can see, on average, people are 61, but it easily goes down to 40 or up to 80. So there's a fairly wide spread here. Just to help you understand standard deviation even a little better, let me just present to you 3 simple little mock data sets. And they all have the same mean of 15. They're just 8 people in each of these data sets. But they all have the same mean, but they have different standard deviations. So in the first data set B over to the left of your screen, the mean is 15, but everybody's really clustered around the mean. So the standard deviation is only 0.9. In the middle one, data set A, the mean again is 15, but there's more spread around the mean. So that increases the standard deviation to 3.7. In the final data set C, over to the right of your screen, the mean is 15, but the standard deviation is 5.1 because you can see nobody's even close to the mean. Everybody's way out in the tails, and that can happen in a distribution, so that's going to make the standard deviation even bigger. So that's giving you a sense of what the standard deviation means intuitively. Okay, another way to measure the spread or variability of the data is just to rank the data and look at percentiles. We did this when we looked at box plots. So you can talk about things like the 90th percentile of the data, where does the 90th percentile lie? That will give you some information, some feeling about the data. So the 90th percentile is the value for which 90% of observations are lower. You can talk about the 10th percentile of the data. That would be the value for which 10% of the observations are lower. We've already talked about the median. That's the 50th percentile. Half are above and half are below the median. So sometimes we'll just talk about where those different percentiles lie to give ourselves a sense of the spread of the data. Percentiles will not be affected by extreme values as we saw with the median. So that's going to be different than standard deviations. So that might be a reason that you focus on percentiles, is if you have extreme values and skewed data, the standard deviation might be a little misleading. You might instead focus on percentiles. And in particular, one measure that's based on percentiles that we use a lot for describing the variability of data is something called the interquartile range. And we saw this when we talked about box plots already this week. The interquartile range is just the distance between the 75th percentile and the 25th percentile, or also known as the third quartile and the first quartile. It's the middle 50% of the data. And again, that interquartile range is not going to be affected by outliers, because the middle 50% of the data is going to be the same middle 50% of the data, no matter how high or low the minimum and maximum values are.